Welcome to We Learning, and I'm Lavanya Elangovan, your science educator. So just tell me, how are you all? Fine. So before that, tell me, am I audible? Is my voice clear? Is my video clear? No glitches here and there, right? Yes? Good. So then we'll just start with our session without any further delay. Great. So what are we going to discuss today? Keep thinking. And you know what We Learning is, right? We Learning is an online education platform where we give quality education for all students. Here at Vista's Learning, we help students like you to stay on schedule, value their time, and also excel in your academics. Right? So do subscribe to our channel. And if you have already subscribed, share it with your friends, family members, and relatives, because someone out there will have the access to quality education. So having said that, let's start today's session. So yes, come on, tell me, like, what are we going to discuss today? Any guesses? Any idea? Good. See, listen, we are going to discuss about atoms and molecules. Right? You'd have heard about this term every time, like from your maybe now you are in 9th standard, right? Maybe from 6th standard, I guess, like this term called atoms, you would have been heard here and there, right? And you also know what are molecules, yes or no? Yes. So because when you're dealing something about water or carbon dioxide or nitrogen, you would have heard this word molecule. But who coined it? Who found this? Where did it start? What exactly is this atoms and molecules? How did they formulate this? How did they find it? Where did they see it? There are a lot of questions in this particular one term atom, right? So there are lot many questions. So no. So you want to know the answer to that, right? We should actually know like from where it started, how it started, and all those things. That is why you've got this atoms and molecules chapter in this class. Is that clear? So shall we just start discussing about atoms? We'll just start, okay? First, so everything actually, we'll just start from the basic, okay? So we don't want to directly pitch into what is atoms. So instead, we'll just start with just telling like what all you know. Okay, so what was your first chapter? Your first chapter was about matter, right? So you studied like is matter around us pure? You studied like other different types of matter, right? So states of matter you know very well. So no, so you know what is matter. So now tell me, what is matter? What comes to your mind if I say matter? Something that is having mass and something that will occupy some sort of space. You say that to be matter, yes or no? Yes. So that is a definition for matter, which you already know, but still I'm telling you just to recap, just like a recap. Okay. Let me take my laser. Yeah. So matter is nothing but anything that occupies space and has mass, right? Yes. So it can be of any state. When we are talking about state especially, it can be a solid, it can be a liquid like this, or it can even be a gas. There are different states for matter. A single substance can exist in different states. For example, you take water. So when you reduce the temperature of water, or normally when you are taking this physical process in water, it will turn itself into a solid. Yes or no? The ice cubes here that you see, this water, right? Ice cubes. And the same ice cubes, if you're just taking it out from the refrigerator and you are increasing the temperature for it, what will happen? It will convert itself or turn itself into a liquid, which will, again, it is one of the physical state. It can easily flow, it has volume, right? So all those things you know very well. And again, if you're increasing the temperature for this particular liquid, what will happen? It will turn into a gas. Yes, and it will mix with the air that is present around. So the same water, it can exist as a solid, as a liquid, and also as a gas. But whatever state it is existing, we call that to be water molecule only. Yes or no? Yes or no? So why do we call it like that? Irrespective of its physical state, let it be solid, liquid, gas, or whatever, we say that to be water molecule only. Why? If it is having different state, we should have different names for that, right? Because ultimately, in the basic level or in the molecular level, it is water molecule only. When it is solid also, it's going to be a water molecule. When it is gas also, it's going to be a water molecule. Or when it is liquid, of course, it's going to be a water molecule. So, yes. So that something is not going to change. That you're clear with this, right? Yes? Fine. So now tell me, whatever is there around you, whatever object it is, like irrespective of the physical state and all those things, you say that to be a substance. Yes or no? Commonly we say substance, right? I'll just show you that slide. So now tell me, like, what is a substance? What is a substance? Something which you cannot break it down. You say that to be a substance. Yes or no? Or we can say a pure form. We can say like that also. Right? I'll just show you here. So these two are the two types of substances. One, pure substance, and the second is mixtures. This also you know very well. So what is a pure substance? Something which exists just like that in nature. You say that to be a pure substance, right? So what is mixture then? Combination of some pure substances. You say that to be a mixture. Correct? Correct? Yes. Yes. So pure substance is something. So now we no need to talk about mixture, because if you break down the mixture, you're going to end in this pure substance only. Right. Again, in pure substance, you have two different divisions. I'll just tell you those also. See here, a pure substance consists of single type of particle. This one you know. Yes or no? So again, this pure substance, you can divide them into elements and compounds. Right? So what is a pure substance? It's going to consist only some single type of particle. So we are just going to concentrate on the particle now. Now we are in the particular level. So first we were in the water level. I mean, like the entire liquid. So that liquid, we are just considering that to be a substance. So anything around you, you can say that to be a substance. So everything you can break them down and you can consider them to be a substance. Again, in substance, it can be pure, it can be impure, or it can be pure, it can be a mixture. So now we are coming back to the pure substance only. Okay, for example, okay, you take water. We are talking about water. Just consider we are talking about the salt water or a sea water. So what will be present in a sea water? Water will be there. Salt molecules will be there. Some decayed plant stuffs will be there. And some microorganisms also will be there. So all together makes the sea water. So now discard all these things. So the sea water together, you will call this to be a mixture. Because it's not pure, it's having so many other stuffs also inside it. So in this, from the sea water, we are just discarding or just trying, we are undergoing some physical processes, and we are removing this decayed plant items and microorganisms. We are removing them. Okay. Now we are having only this salt and water. Only this two we are having. So this two, we'll consider this to be a pure substance. Okay, after we are reducing it, after we are breaking it down, we are resulting, or what is present in our hand is a sea water, which is having only salt and water. So the salt and water, again we can say them as compounds and elements. Clear? So from this sea water, let's take only the salt. How we will take the salt? Very simple process called evaporation. We'll take only the salt now. So in this salt, you again say that to be a compound. Why? Because you have got this NaCl. I mean sodium and chloride. Combination of both sodium and chloride. Right? So when we are breaking them again into two, we'll consider them as elements now. We'll consider the sodium as a separate element, this chlorine as a separate element or an individual element. Clear? Let me just take my pen. Okay. I'm just trying to look at my width. So now this Na is a separate element that you know, and the Cl is again a separate element. So now we are going to look at this stuff in an element level. So here where the atoms picture in an element level. When we are trying to break down this element into more and more simpler compounds, only then we'll get an atom. So now can you imagine how small an atom will be, or from where exactly we are getting an atom? I'll tell this again. Okay, just have a deep breath. I'll tell in a very crisp, short manner so that it will register in your mind. Okay. See, you are collecting some sea water from the beach in a tumbler. So randomly you are collecting it. So what all will be present in it? So now in this stage, you are calling that to be a water. We'll also name that to be a mixture. Why are we saying that as a mixture? Because it's going to have salt, water, microorganisms, some decayed plants, some shells also it will have, sand also it will have, because you're randomly collecting. So now we are removing, breaking the entire mixture into simpler compounds, or you're just naming them. So as you are naming them one by one, and you're removing them by so many physical processes, the last thing that remains in your hand is a salt water, which has only water and salt. So the salt and water, we'll call that to be, or we'll categorize them under pure substance. Right? So again, this pure substance is going to get subdivided into two. One is elements and the second is compounds. Clear? So when we are just subdividing these compounds and elements, we are just going to reduce the sea water into more simpler stuff, or we are just trying to extract something from there. What are we trying to extract? The salt. So by evaporation method, water vaporizes and only the salt we are getting it. That salt, we'll say that to be a sodium chloride. It can have other minerals also, but still we'll simplify. We'll say like only sodium chloride is present in it. Clear? So this sodium chloride, again we are simplifying them. So this sodium chloride will be a compound. So when we are simplifying them, we'll get sodium separately and chloride separately. So what is this sodium and chloride? We'll name them to be elements. Clear? So this is an element. Is that clear? Clear now, right? So next. So what are elements? Elements, you know, the simplified form which we cannot actually break down. And you know how many elements are there around us? There are totally 118 elements known so far. We know them to our knowledge, to like whatever the scientists have made the research and they have found, it is around 118 elements known so far. There are more, there might be more, we don't know. The research they are doing researches, but still till 118 it is there. And in which 92 occur naturally. So what about the remaining? It will be unstable. The remaining stuff, it can either be unstable or it will be in a combined state. Fine. Only 92 of the elements occur naturally. Other are in the combined state, or they are unstable, or even man is synthesizing it, or man formulating it. Clear? So next. See, for example, in elements, you know this one. See, we are saying carbon. And why do we say carbon? We are just picking the first letter of the C and saying it as carbon. And calcium, again, we cannot say the C because we have C for carbon already. So we are just picking the Ca and then we are saying that to be calcium. Sodium, so there will be direct names like from the, from the first letter. We are just picking it up and saying hydrogen, we say H. Oxygen, we say O. Sulfur, we say S. So we'll just randomly pick the first letter alone and we'll name the element. Sometimes we'll take the Greek or the Latin names. Okay, see here for sodium, we don't say S or we don't say SO. We say Na because sodium is something which the word is actually natrium. The exact name for sodium is this natrium. So natrium is something which we are getting from the Latin name or a Greek name. So So when we are deriving it from other name, obviously the symbol is going to be different. Okay, you say for gold. Gold, we don't say G. Instead, we say that to be A. Right? We say that to be AU, which is OR. Right? So like that. So it will be different. So about elements all we'll be learning when you are learning the periodic classification. In your 10th standard, you will learn in depth. So here, this is just an idea for you to understand and have it in mind. Okay. So the next one. So now, atoms. An atom is the smallest unit of matter that retains all of the chemical properties of an element. So when you are subdividing that particular element, where will you go and end this particular place called as an atom. Okay, again about atom, the existence, the size, the everything will be the properties, everything we'll be learning in the next session, because there where we'll be discussing all about atoms. This session is all about how did they come to an idea of an atom. Is that clear? Fine. So just make a note of this definition. It will be useful for you. I'll just tell it again. An atom is the smallest unit of matter that retains all of the chemical properties of an element. Clear? Fine. So the next. See, around 500 BC, some Indian philosophers and Greek philosophers are more or less in the same time. Okay. So they started thinking about all these things. Like, how is a particle existing? Or how is it getting combined with one another? How are they getting mixed? So all those things they started thinking and they started formulating. So likewise, one such Indian philosopher is Maharishi Kannada. So what did he formulate? It was like, when he was normally meditating or when he was having his food, it was said like that, like when he was having his food, he started chewing it and he found that the smallest particle cannot be further divided. Okay, so he came to a conclusion that something, so whatever you take, we can break them down. And as we are breaking them down, it will end in the smallest particle. So that particle, you cannot further subdivide. So that is what he postulated. Okay, so he was Maharishi Kannada and he is a person. Okay, so he said that particular matter or whatever the substance around us to be a padarth. Right? And that particular padarth, the smallest division, which like after that we cannot divide at all, there is something he striked his mind. No? So that one he named it to be Paramanu. Clear? Yes, so this is what he formulated around 500 BC. So there were other Greek philosophers also around the same, like Democritus, who came to a conclusion like, again, the smallest particle is there. Let's name that to be an atom, like that. So atom is so known so far. It is like, according to their vision, it is the smallest particle which came to their mind. Clear? So now, as years passed, so many researchers they exactly found like what is the smallest unit, and they found everything. A lot of researchers done. Now we are following a lot of things, right? So we'll be discussing about all those things as well. So now, chemical reactions. So what is this? All of a sudden, some chemical reaction is coming from atom to chemical reaction. What is the relation? You might think. I'll tell you. See, when the scientists started researching all those things, the first question or the question that struck their mind was like, how is the reaction happening? How is one molecule getting combined with another molecule? How are they existing? Or how are they stable? What makes them unstable? What is making them dissolve, or what is making them to evaporate? So all those things only came to their mind. So they grouped all these things under reactions. Right? So we'll start our lesson from the reactions only. Like, how did this reaction exactly started? Okay? So in a chemical reaction, two or more molecules interact to produce new compounds and are called reactants, whereas newly formed compounds are called products. So this is something which you already know. Whenever you're writing a reaction, you obviously have reactants which will combine together to form products. Yes or no? Yes. So we'll be looking about that only here. Fine. See, look at this reaction. So in this reaction, this is carbon. Okay. So this carbon will get combined with this oxygen to form carbon dioxide. Clear? So carbon dioxide is a separate molecule. Carbon and oxygen are also like that only. They are different elements. Or we can say like the reduced form, we can say atoms also. So when carbon and oxygen are combining together, we get a new compound called carbon dioxide. So in this carbon dioxide, carbon is there, oxygen is also there, but they are combined together. So here we'll say this to be, so we'll say this to be the reactants. And this one, we'll say that to be the product. So when two or more reactants combine together, they give a product, which will have the characteristics of both the reactants, but it will be a new product. Is it clear? Yes. So next. So this, he's a physicist and chemist, Anthony Lavoisier. He came across all these chemical reactions and he formulated a very good, very important theory. Okay, under which we will be reading it under this law of chemical combinations. Okay, so under this law of chemical combination, we'll be learning two laws, one of the major important laws. And Lavoisier, another scientist, they worked together and they formulated this laws. Okay, we'll be learning. Yeah. So Joseph Proust. So these two scientists only gave two laws, which we are grouping them under laws of chemical combination. Right. So now, what are those laws under laws of chemical combinations? See here, law of conservation of mass. Number 2, law of constant proportions. Very simple, very easy laws. We'll be seeing one by one now. So now, law of conservation of mass. What does that mean? So law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Just recall the combination of carbon and oxygen, it gives carbon dioxide, I said. So here, the mass of carbon, mass of oxygen combines together to form the mass of carbon dioxide. So the mass of the products is no way gonna be higher or lower. It's going to be the same of the sum of the reactants. Is that clear? So mass of the chemical combination before reaction, after reaction, they are going to remain the same. Maybe the change in the physical state might occur. But when we are calculating every negligible change, the mass is not going to change at all. It is always going to remain same before and after the reaction. So that is why he's saying like mass can neither be created nor destroyed in a particular chemical reaction. It's always going to be same. Is that clear? Yes? Fine. We'll proceed so you will understand. Okay. So the next law, law of constant proportions. So what is this proportion called as? For example, your mother is making tea for 4 people. So she'll use a reasonable amount of milk, sugar, tea powder, right? And some water. What if some relatives are coming to your house? For example, we'll say like 4, normally 4 of them are there. 4 more are coming. So totally 8 of them are there. So for this 8 of them, what will your mother do? What will she do? She'll actually double the quantity, right? Double the quantity of milk, sugar, tea powder. So here the ratio is going to remain same. The proportions are going to remain same to make a good tea. Even if one ingredient, some proportion is reduced, the taste is not going to, the exact taste we are not going to get. So the ratio of everything there must be good. Yes or no? Or the ratio of all the ingredients there must be in its own proportions, or it must be in its own ratios. Clear? So that is what this law of constant proportion says. See, look at this here. In a chemical substance, the elements are always present in definite proportions by mass. So make a note of these laws, because these are really important. So in a chemical substance, the elements are always present in definite proportions by mass. So next, see here, water molecule is there. Oxygen we have, only when hydrogen combines with oxygen, you will get a water molecule. Yes or no? So relate this example with this law of conservation of mass and law of constant proportions. I'll tell you now. What is the mass of oxygen? 16. What is the mass of hydrogen? 1. Right. So here, what will you say? H and H, you will get 2 molecules of hydrogen and you will get 1 molecule of oxygen. So when you're writing in terms of ratios, how will you write? You will write it like this, 1 is to 8, because here you will write like 2 and you will get is 2 is to 16, right? So you can cancel it, you will get 1 is to 8, which is really simple. So the ratio of this water is not going to change. Recall the first thing that I said, solid, liquid, gas. So wherever you take as a vapor, you trap the water and see, it's going to be in the ratio of 1 is to 8, which means 2 molecules of hydrogen is going to get combined with 1 molecule of oxygen only. Nowhere it's going to change. Even if one thing is changing there, 1 oxygen is added extra, 1 hydrogen is added extra, the entire compound is going to change. Which means we are not going to get the exact compound or what we want. We are not going to get that. We'll get something else. So wherever the water is, as a solid, as a sea water, as a vapor, as a liquid, as a river, as wherever it is, the water's composition and the water's proportion is not going to change. The mass is not going to change. How much grams of oxygen, how much grams of hydrogen, what is going to get combined there? It's not going to change at all. This is clear, right? So the next one. Same thing for this ammonia also. See, 1 molecule of nitrogen always combines with this 3 molecules of hydrogen. Only then it can be an ammonia. So the mass for ammonia, so mass for nitrogen is 14. For hydrogen is 1. So this ratio will be like 3 is to 14 or 14 is to 3, whatever. Is that clear? Yeah, 14 is to 3. So if the entire weight of ammonia is 17 grams, let's say, so and you are allowing it to decompose. So when it is decomposing, you will obviously get this 14 molecules to be ammonia, the N, nitrogen, and the remaining 3 will be hydrogen. Now is it clear? Both the laws, right? Next. This is an ammonia molecule that so this is one of the most important famous scientists, because now what all we are learning about atoms and all those stuffs is all because of his postulates only. So he gave us 6 postulates. Okay. So we'll be learning about atoms in detail, like who all gave the structure of an atom in our next chapter. We learn about atom in the next session. But still, just know this postulates. I'll just tell you those postulates now. And I wanted you, when you're coming for the next session, you just have to elaborate that. Just type it in the comment and let me see. Elaborate those postulates. Give examples for that. Okay. So we'll again start with these postulates in the next chapter. But still, let me give you a very small gist about those postulates. Number 1. 6 postulates. Okay, total. All matter is made up of very thin particles, very tiny particles called atoms. This you know, yes, when we are reducing it, compounds to elements, when we are reducing again, we are going to result, that is going to result as in an atom. Number 2, atoms are indivisible particles, which cannot be created nor destroyed in a chemical reaction. Yes, they can combine to form a new product, but they cannot reduce themselves, they cannot destroy. So atoms can never be destroyed or created, but we can form different products out of it by the combination of different chemical reactions. Number 3, atoms are of a given element are identical in mass and chemical properties. So they are going to remain same, which means the mass is always going to remain same before and after the reaction. So atoms of a given element are identical in mass and chemical properties. Fine. So the 4th one. Atoms of different elements have different masses and chemical properties. So if, for example, the 3rd postulate said like, if you are taking a gold element, so whatever you are doing, wherever you are cutting it and seeing, it's going to remain uniform. The chemical properties, physical properties are going to remain uniform. But when you are looking at the combination of a different element, like say gold and silver, there the elements are going to be different. I mean, like the atoms are going to be different. The chemical properties, the structure, everything is the arrangement, everything is going to be different there. Is that clear? Yes. So atoms of different elements, obviously they are going to have different masses, different chemical properties. Same element, they are going to remain same. Fifth, atoms combine in a ratio of small whole numbers to form compounds. See, there I said carbon combines with oxygen to form carbon dioxide. One complete molecule, carbon, is going to get combined with two molecules of oxygen to form carbon dioxide. So here half a molecule of carbon, quarter molecule of oxygen, 3/4, it cannot combine like that. So it's going to combine in a whole numbers. Clear? Last, the relative number and kinds of atoms are constant in a given compound. Okay, so the relative numbers and kinds of constants, the kinds of atom and the numbers of relative numbers of the atoms in a particular compound, they all are going to remain constant in it. They are not going to, the proportions or the difference is not going to happen. They are going to remain constant there. Is this clear? Fine. So good. So in our next session, we'll be discussing all about atoms, their existence, their presence, the size, the way to write it, what all are present, subatomic particles. So we'll be we'll be listening about all those in our next session. Fine. So we've come to the end of the session. Clear? So in our next session, we'll be learning about atoms, and just look at other subjects also, physics, math, and biology. Like those videos, like this also, and share it, subscribe it, and don't forget to hit the bell icon. Right? So until and unless I meet you in my next session, this is Lavanya Elangovan signing off from Peter. Bye bye.